Hello, calculus students. We are still in chapter 3, which is everything you've ever wanted to know about derivatives. And now we've gotten to section 3.9. If you recall, 3.8 was inverse functions. Well, we're still there, but inverse trig functions. What's an inverse trig function, you ask? Well, you remember your friend f of x is sine of x. But do you also remember the function sine of x with a little -1 there? That was called inverse sine, or the word we like to use is arc sine. What did it mean? This is what it meant. If you do sine of, let me just pick an arbitrary angle that we can do, pi over 3, and want to calculate that value. If you don't have it memorized, we know it's a 60-degree angle. So on a triangle, if that's a 60-degree angle, on a right triangle, I can take that triangle and label my sides. Opposite of a 30-degree angle, that would be this one right here, would be a 1. Hypotenuse is 2. The other leg is square root of 3. So the sine of a 60-degree angle, or a pi over 3, is opposite over hypotenuse. In this case, would be square root of 3 over 2. The sine of a 30-degree angle, or pi over 6, opposite of the 30 degree is a 1. Hypotenuse is a 2. So what does that have to do with the inverse sine? If I do the inverse sine of a square root of 3 over 2, the question is, what angle gives you that sine? It's the inverse. It's asking for the angle. Well, that answer would have been pi over 3. If I say the arc sine of pi over 6, then that would have been 1. I'm sorry, not arc sine of pi over 6, back up. Arc sine of the answer, which is 1/2, would be the angle of pi over 6. The answer to an arc sine is always the angle that would have generated this. Let me just give you a few more things. We remember that the tangent of a 45-degree angle, do you remember what that one was? 45-degree angle, that means this angle and this angle are the same to add up to 90, because that's right. So 1 square root of 2, the tangent of a 45-degree angle is a 1, opposite over adjacent. So therefore, the arc tangent of a 1 would be 45-degree angle, if you're in degrees. Okay, enough review. You probably weren't exposed a lot, but here's a picture of sine, but it only gives you from a negative pi over 2 to pi over 2. That's because if you go to the unit circle, the sine of this quadrant is positive, and the sine of this quadrant is negative. Therefore, from a negative, if we say negative pi over 2 angle, all the way to a positive pi over 2 angle, which, by the way, is 90 degrees, gives you, it's called the, it's the primary domain of sine. Normally, we don't think of it. We always think of sine, how sine goes up and sine goes down and sine comes back up. And we like to think of it between 0 and 2 pi, but that's not the primary domain, even though these are positive and these are negative sines. It goes from negative pi over 2 to pi over 2. And your cosine, and so here's my domain that we use for the primary domain. The primary range doesn't change, -1 to 1. Here's your cosine. Normally we think of cosine as starting at the top, coming down, going back up, starting over again. However, from 0 to pi over 0 to pi over 2 is the middle, to pi gives you, it's your primary domain of cosine. On the unit circle, it looks like this, from 0 to pi. So these two quadrants become the primary domain of cosine, because now you have positive cosines, you have negative cosines. The range is still -1 to 1. Tangent works just like sine. -pi over 2 to pi over 2. And you need to, one thing about tangent, it's asymptotic at pi over 2, because the tangent of a 90-degree angle, if you recall, on a unit circle, 90 degree or pi over 2 is here. That ordered pair is 0, 1. And tangent is always y over x. So tangent of 90 degrees, y over x, gives you 1 over 0, which is undefined. Therefore, that's why we have asymptotes there. And also it happens at -pi over 2. You know it better as 3 pi over 2. Tangent is undefined. At both pi over 2 and 3 pi over 2, but we call it -pi over 2 and pi over 2. So there's your picture. And the range, well, since it's asymptotic, it goes forever down and forever up. Those are your basic review of your principal domains of, I said primary, but it's actually principal domain that we use. And it corresponds to the range of my inverse function, because if the x's change places with the y's, then it makes sense that if you're doing the arc sine curve, which is, where's my arc? Well, no, I don't have that yet. I'm still looking at trig functions. Okay, let's see. Sine, cosine, tangent. Your cotangent's very similar to tangent. If you remember in your college pre-cal class or your regular pre-cal class, it just flips over. The cotangent did. Secant and cosecant, they also just flip over each other. And I don't want to go into a whole lesson on graphing secants and cosecants. Frankly, if we can get through sine and cosine and tangent and do the inverse, we'll be doing really good. Move on to those pictures of our inverses. If sine, the domain went from -pi over 2 to pi over 2, it makes sense that the range of the arc sine, the inverse sine, goes to -pi over 2. And the domain would be what the range used to be on sine, -1 to 1. And the picture, it's really a tough graph to do in your calculator. You hardly can see anything if you actually graph the arc sine. And you can, but I can't show you in this video because this won't record my calculator through this program. But anyway, arc sine, basically, it actually has a dot there. It actually is starting here. It doesn't go past it. That's pretty much the only part you'll ever see of that graph. And that's the arc sine. It flips to do the arc cosine. And arc tangent is a weird looking animal because you used to have the tangent had vertical asymptotes. So what happens on the arc tangent? You have horizontal asymptotes. And the domain goes from negative infinity to infinity, because the range went from negative infinity to infinity. Your range becomes -pi over 2 to pi over 2 because your principal domain of tangent was -pi over 2. But remember, that was asymptotic at those places, and the function went like that, as you recall. Okay? Yeah, he gives you every picture. I'm not going to spend time with all 6. Even though this lesson in the book doesn't even cover the sine and arc sines because they think they already talked to you before in another lesson. Let me highlight the sine and the arc sine back to back so you can visually see that my domain became the range and my range became the domain. I don't need you to know much more than that. I'm not going to ask you to be graphing them. The cosine graph, so here's your primary domain from 0 to pi. So from 0 to pi becomes my range of my arc cosine graph. Likewise, my range from -1 to 1 became my domain -1 to 1. And then the tangent is asymptotic, so it goes like that forever. So my domain from -pi/2 become my asymptotes -pi to -2, -pi/2 to pi/2. And my range, which goes from -infinity all the way down here, all the way to infinity, becomes my domain -infinity to infinity of my arc tangent. This is purely a full review of what you would have had in pre-calculus. All right, and there's a whole page highlighting the tangent, the cotangent, secant, and cosecant in your book. Okay, I'm not going to, you can study this if you want, but that's not calculus. That's pre-calculus. The first example in the book wasn't calculus either. First example in the book said how to compare two values of arctangent. I did that already for you. Matter of fact, he did tangent of pi/6. He's writing it as 1/3. How did I do pi/6? I did it as a 30-degree angle. 1, 2, √3. And tangent is opposite over adjacent. It certainly is 1/3. Therefore, the arctangent of a 1/3. Oh, he's doing a negative. He's doing the tangent of a negative 30-degree angle, which just means it went down in this quadrant here. So now that's 30 degrees. And if you label your sine, this would be, well, he's doing pi/3, so that's a 60-degree angle. So sorry, 60-degree angle. That makes that a 1. That makes that a 2. That makes that a negative √3. That's why you get it. And so looking at the table, he's showing you basically how you could graph the arctangent. He just chose some values like the pi/6 and the -pi/3, because you can pick any angles you want in this side of the circle. You could pick pi/2. You could pick not that it's that exciting at pi/2, because what happened at pi/2, it's undefined. You could pick pi/4, -pi/4, pi/6, -pi/6. You could choose all of those, and you could graph it. Again, that is not calculus, but nonetheless, he graphed the arctangent based on these values. Play around with it if that's exciting to you. I'm going to go right to the calculus. Okay, so here, from here to here, is the picture of your arc sine. And he wants to calculate the derivative of arc sine. The book decided to introduce you to it by using that formula that we had of the inverse derivative is equal to 1 over the derivative of f of the inverse. And so if you were to do it with that formula, that you want to do the derivative with respect to x of arc sine, then what you would have to have is the derivative with respect to of sine, because your formula has the derivative of f. So this becomes, f becomes my sine, and then this arc sine is my f inverse. So F inverse would be my arc sine. If you want to use the textbook's definition, then you do it the same way we did the problems. F, the derivative with the inverse plugged in. So the derivative of sine is cosine, and there's my arc sine being plugged in. Here's where it gets in trouble. How do I go from this step to this step? He gives you this equation here, but I guarantee you could stare at this for an hour and you're going to say, how did he get this? Did he memorize it? It's very complicated to go from this here, using this, to here. So I'm going to show you my method. This is the textbook's method. It's very confusing. So the very first one I did with take you through my method. Here's how I do it. If y equals the arc sine of x, and I want to find the derivative. Find the derivative. Here's what I do. I realize that my main function is y equals sine of x. The inverse means the x and the y's change places. So I write x equals to the sine of y. So if I want to find the derivative, I take the derivative of both sides with respect to x. What's the derivative of x? 1. What's the derivative of sine of y? It's cosine of y, and chain rule says y prime. Now I solve for y prime. Y prime is 1 over cosine of y. Well, what does that mean to you? It doesn't mean much. So what I have to show you up here is that if y is the sine of x, and I rewrote it as x equals the sine of y, what happened is my angle now became y. So I'm going to go to this first step right here where after I switched the x and the y, and I draw a picture of what this means. My angle is y, and the sine of y is opposite, right here, over hypotenuse. Go back and look at this picture. It's x over 1. X over 1. Now, using your knowledge of Pythagorean Theorem, we know that a squared plus b squared has to be c squared. What am I missing? I'm missing one of the legs. So technically, if I'm missing one of the legs, a or b, it doesn't really matter. Let me say I'm missing the a. I don't know what a is. So I move the b squared over, so a squared will be equal to c squared minus b squared. And then I take the square root of both sides, so my a will be the square root of c squared minus b squared. You don't have to do that every time. You just know that I'll take my hypotenuse. I'm going to take this hypotenuse, which is 1, and I'm going to square it. And I'm going to subtract this leg squared. So that becomes a is equal to 1 squared, which is 1, minus x squared. But then I have to take the square root of it. There's my other leg. So what I have done is I created a new triangle that used x equals to the sine of y. So I have my new triangle perfectly laid out. So now go look at my answer. My answer for the derivative is 1 over cosine of y. Go back and look at that triangle and say, well, what is the cosine of y? It's adjacent over hypotenuse. The cosine of y is adjacent over hypotenuse. So that becomes 1 over the cosine, which is adjacent, which is square root of 1 minus x squared over 1. Well, that doesn't do anything. The answer is 1 over the square root of 1 minus x squared. There's my derivative of arc sine. Okay. Now, that was a lot to chew off of, but the arc sine. 1 minus, there it is, 1 minus something squared. But sine was 1 minus x squared, and do another one here. Let's see, let's do the arc cosine. He doesn't even do this one in the book. So I'm going to go real slow. Start out with y equals the cosine. Switch the x and the y around. Draw that picture. Right triangle. My angle must be called y. So there's my angle. And the cosine of y is x over 1. Cosine means adjacent, x, over hypotenuse, 1. That means this opposite side of the angle must be the square root of the hypotenuse squared, 1, minus this leg squared, x squared. So now that I drew that picture, I will now do the derivative from left to right. I'm going to do the derivative of this side, and I'm going to do the derivative of this side. So the derivative of x is 1. Derivative of cosine of y is negative sine of y. Chain rule, y prime. Y prime is negative 1 over sine of y, or 1 over negative sine of y. But I put the negative on top. But I need it in terms of x's and y's, not with trig in it. So I go back to my triangle and say, what is the sine of y? Sine of y is opposite over hypotenuse. That becomes negative 1 over the sine of y, which is square root of 1 minus x squared over 1. But that doesn't matter. It doesn't change anything. So I can just leave it as that. Okay? So let's see what else. Here, it's almost like cosine is, there's a negative up here. 1 minus x squared. That was the cosine one, right? So the answer is the same as sine, except for there's going to be a negative here. There's also something else I thought was different. Okay, as I said, arc sine and arc cosine are the same, except for arc cosine has a negative there. So if I go over to that up here, arc tangent. Okay, this time I'm not going to do as many steps. Y equals tangent of x. The inverse means switch the x and the y around. Draw the triangle that represents this situation. Angle y is right here, is opposite over adjacent. X over 1 becomes x over 1. Now what does my hypotenuse become? A squared plus b squared has to be c squared. So therefore, this has to be x squared plus 1 squared. A squared plus is c squared. So I still have to do, if I say a squared plus b squared is c squared, c is going to have to be the square root of this. So boom, square root of the sum. The other ones were square root of the hypotenuse squared minus the other leg. But this is plus. So I need that picture because I'm going to do the derivative. Here goes. Derivative of x is 1. Derivative of tangent is secant squared of y. Chain rule, y prime. Y prime is 1 over secant squared y. Okay, secant is the reciprocal of cosine. Cosine normally, it always is, of this angle would be adjacent over hypotenuse. Secant will be the reverse. So it's 1 over hypotenuse over adjacent. Square root of x squared plus 1. But I have to square it. So the arctangent derivative turns out to be 1 over x squared plus 1. Those are your basic three that I really do care about. This is what I have. That was that we did. That we. Yes, there's more. He does the, what is this one? Oh, that's back to the arcsine. Okay, back to the arcsine for a minute. As you know, that I just proved this to you. If I go back a couple slides, 1 minus something squared, the derivative. But FYI, sometimes you don't have an x. Sometimes you have something more than just x. Yes, if it was just an x, then if I use the chain rule, the derivative of x is times a 1. But what if it's not an x? What if it's something else than x? Then you're going to have to do the derivative of whatever was there. This is the generic answer instead of the one I did for you. Okay? So you got to pay attention to that. Just like before, it happened to us before. We learned how to do e to the x, and then all of a sudden we had to do e to the u. Okay. Okay, he's talking about some interesting stuff that I'm not going to talk about today. I didn't have in our book. Let's see. What is this one? Well, it's the same. It's the same. I don't know why I put the problem there again. I think I was going to try to make up a problem. I don't remember what I was going to do on this slide. He didn't give me, the book does not have the generic answer in a box. Like if I go to the cosine, then I can say if y equals to our cosine of u, then y prime would be a negative 1 over the square root of 1 minus u squared du. Okay? Now, interestingly enough, you multiply this by du, sometimes the du can be in the numerator. But we'll cross that bridge. Oh, you know what it was? Slide. There's the arctangent. Remember how it was 1 plus x squared in the bottom? But again, x may be bigger than just x. It may be a function. So you still have to multiply your answer by du. Okay? If you go back there, just like I said right here, the du kind of is up there in disguise. There's your arctangent. With the u could be other things. So now, knowing that, let's do a harder problem. Let's do the arcsine of x squared. So you have two choices. You could memorize the answer. Okay? A lot of kids, they know this is not going to be on the AP test very much. So if I just memorize arcsine, arccosine, arctangent, I'm good to go. Yeah, that's true. You can. So if I just memorize and follow the answer here, it should be that the derivative of arcsine of x squared should be identify u. U is x squared. And du must be 2x. Right? So if I just plug in my answer here, should be 1 over the square root of 1 minus. Now be careful. U is being squared. This u is not squared. U squared would be x to the 4th times du, which is 2x. So it would not surprise me if you would leave the answer as 2x over square root of 1 minus x to the 4. So you could look at a table of values or a table of formulas and say, oh, I can do that without doing any calculus. Let's see if here it matched it perfectly. Which way did you like to do? Everybody says, oh, I love this method. You know why I can't do this method? I have Teflon brain. I can't memorize formulas. I can do it the long way, just to make sure that if I still got it. And I don't care how you do it, to be honest with you. If you memorize them, that's fine. If you derive it like I do, that's fine too. So if y equals to the sine of my x squared, because that's my angle, and I really want the arc sine, so I switch the x and the y. Switch the whole angle. X squared equals sine of y. That's important. If you forget to do that with my method, you might make a mistake. And then draw that triangle. Draw that triangle with my angle being y. Right triangle. X squared over 1. Sine is opposite over hypotenuse. The other leg must be the square root of take the hypotenuse and square it, 1, minus take this side and square it, x to the 4. Well, that looks familiar. Now do the calculus. Derivative of x squared is 2x. Equals to the derivative of sine is cosine of y. Chain rule, y prime. Y prime, the derivative, is 2x over cosine of y. Go back to my triangle here and ask myself, what's the cosine of y? The cosine of y is adjacent over hypotenuse. Cosine of y is nothing more than the square root of 1 minus x to the 4th. Take that answer and plug it back in. 2x over the square root of 1 minus x to the 4th. Did that match the answer? So I have to have my method. Oh, you could always do the textbook method. That was a bear, let me tell you. Continue. He wants me to do the arctangent of that. I just did this. Oh, I have this problem. Why do I have it here again? It's the same thing. Okay, harder one. Ooh, secant. We haven't even looked at arcsecant. This should be fun. Now, he gives you the answer in the chart. You can memorize that. It's sort of confusing, to be honest with you. Look all you have to worry about. You have to identify what u is. Okay, u is 5x to the 4th. Then du must be 20x to the 3rd. Okay, that's fine. If you look up in here, you're going to need a u squared. See that? So I better write that out because I might forget. U squared is going to be 5 times 5 is 25. X to the 4th times x to the 4th is x to the 16. Okay, I have everything I need. I have the answer. I know the answer is going to be a 1 over the absolute value of u. Okay, the absolute value of u is the absolute value of 5x to the 4th, which is always going to be positive anyway, so I don't need to put absolute value, but I will for the sake of argument. Square root of u squared is 25x to the 16 minus 1 times du. Okay, so that du is 20x to the 3rd. Is that what I said? 20x to the 3rd? Yes, that's going to actually be on top. Times 20x to the 3rd. That seems fine to me. But anybody can do that. Why don't we do calc? Questioning myself. Did I square this one right? I think I messed up. X to the 4 times x to the 4 is x to the 8. My goodness. I'm so glad I've caught my own answer. 25x to the 8. I caught my answer, but I know you're probably yelling at the computer. Oh well. Well, it would if I simplified. Because the absolute value, I told you the absolute value of this is always positive. So 20 divided by 5 is the 4. X cubed was over here, wasn't it? Yes. And I have x to the 4. That leaves an x down here. Since it's just the x to the 1, I probably would put it in absolute value just to make sure. And then you got the square root of 25 minus 25x to the 8 minus 1. That works for me, I think. I think I have the answers here somewhere. Let's do it again. Yay, let's do it again. Y equals to the secant of 5x to the 4th. I switch the angle with the y, so that becomes 5x to the 4th now is equal to secant of y. May as well draw my triangle. Here's my y. Secant is the reciprocal of cosine, which is normally the adjacent over hypotenuse. So this must be my hypotenuse over the adjacent. 5x to the 4th over the 1. This side must be the hypotenuse, the square root of the hypotenuse squared minus the leg squared. So that becomes 25 x to the, what is, did I do the right power before? X to the 4 squared, is that x? I don't know if I did it right on the other page. No, I'm only human. At least I caught my answer here. All right, so I got my 3 sides. Time to do calculus. Straight across. The derivative of 5x to the 4th is 20x to the 3rd. The derivative of secant is secant tangent, secant y, tangent y. Chain rule, y prime. Chain rule was over here too, but the derivative of x is still a 1, so it doesn't matter. Go back to my triangle and realize, oh, I got to solve this for y prime. Y prime is 20x cubed over secant of y, tangent of y. So let's go up here and just say, what is secant of y? Hypotenuse over adjacent, 5x to the 4th. What is the tangent of y? Tangent of y is opposite over adjacent. That's the square root of 25x to the 8th. So I go over here and I plug that in. I say equals to 20x cubed over 5x to the 4th times the square root of 25x to the 8. Whoop. And let's see, anything simplify? 20 and the 5, that becomes 4. And the x to the 3rd cancels out some of the x's here. So technically, I didn't do that on the other side. I could have done that. I don't know why I didn't do it. 20 square root. I'll bet you some of you are yelling at the computer screen and saying, why didn't you do that? What did I do wrong here? It's 25, my 25 x to the 8. I forgot to put the minus 1. I knew it looked funny. 25x to the square minus 1. Okay. You go back to the other problem. Does it match? I agreed with it. There's his answer. Yep. Of course, he did it. He did it with that other formula. He just plugged in. I don't think he really did the. I don't think he really did the definition. Let's see. Is there anything left? Here's what all textbooks have. They give you the chart of all of them. That's what I told you. On the AP, you should be able to do the first three. Okay? Even if u is not an x, you should. Those are what you really, these are the three you'd want to memorize if you were to memorize. I just prefer doing it. Okay? Now let's not do these. Cross those off. Here's your work from the textbook. And tell you what, if you're going to use the table and just get the answers, that's fair game. But I'm going to ask you to show me the calculus that I showed you for that one and one of the arc signs. And I don't have a tangent. Okay, just those two. Okay, so those two I want to see all the work. The other ones you can use the chart. Okay. Next page. Oh, here's one for you. I want to see that one. There you go. Interesting. Never mind. You're gonna have to do these. This is well, that's the only one that's arc tangent. That's arc cosine. You know what? I don't know what the best way for those are. Go ahead, try them. You may have to ask me a question. Anyway, I'm calling it quits. It's been a long day. And the reason why you're getting this video is because I won't be there today. Bye.